Hello everyone, welcome to today's presentation. This video is about circles, chords, and linear equations. The figure below shows an arc of a circle through 3 points A, B, and C. So we have the diagram as shown. Calculate the coordinates of the center of the circle. So in this question, we are going to apply a property that states that the perpendicular bisector of a chord in a circle passes through the center of the circle. So if we consider chord CB, then the perpendicular bisector of this chord will have to pass through the center. So let's call the center XY. The same applies to chord AB. The perpendicular bisector of chord AB will have to pass through the center. So the idea here is to determine the equations of the perpendicular bisectors and then solve them simultaneously. So this is what we are going to do. For chord CB, we'll require to determine the midpoint. Now the midpoint will be a point on the perpendicular bisector. Therefore, applying the midpoint formula, we'll have x1 plus x2 over 2, y1 plus y2 over 2. So this is the formula we apply to determine the midpoints. So for line CB, the midpoint is 4 plus 3, which is 7. 7 divided by 2, that is 3.5. And then for y, we have 10 plus 8, which is 18 divided by 2, 9. The same applies to this other chord. We'll have chord AB, 2 plus 3, 5 divided by 2, 2.5. And then 5 plus 8, 13. 13 divided by 2 is 6.5. Now these already are points on the perpendicular bisectors. So what is remaining is to determine their gradients. So we'll begin with gradient of this line here. Let's call it line 1, this perpendicular bisector. And let's have this other one as line 2. So beginning with line 1, we will first of all consider the gradient of this line CB. So let's call it M sub CB. So the gradient of line CB, this will obtain as change in y over change in x. Change in y here is 10 minus 8 over change in x, 4 minus 3. And this should give us 2. Now, line 1 and line CB are perpendicular to each other, and we know that the product of the gradients of perpendicular lines will always be -1. So if we take the gradient of CB, that is 2, times gradient of line 1, that should be -1. And this means that M1 is -1 over 2. That is dividing both sides by 2. So having known the gradient of line 1 and also a point on the line, which is 3.59, we can now determine the equation of the line. We also need to consider an arbitrary point xy. So change in y over change in x, that is y minus 9 over x minus 3.5 should be equal to the gradient, which is -1 over 2. So cross multiplying, we'll have 2y minus 18 is equal to -x plus 3.5. Now, bringing x to the left hand side, we'll have 2y plus x, and then 18 crosses, so that we have 21.5, that is 18 plus 3.5. Now we can call this our first equation. Now our second equation will obtain from line 2. Following the same procedure, we first of all determine the gradient of line AB. So let's say gradient of AB is equal to change in y over change in x, 8 minus 5 over 3 minus 2. 8 minus 5 over 3 minus 2, and this is 3 over 1, which is 3. And therefore, since the line AB and the perpendicular bisector are perpendicular, then the product of their gradients is still negative 1. So we'll have gradient of line AB 3 times gradient of line 2 M2 equal to negative 1. That means M2 is negative a third. Now with this again, we can determine the equation of line 2. Now remember, we have a point on the line that is 2.5, 6.5. We also consider an arbitrary point xy. So change in y over change in x, that is y minus 6.5 over x minus 2.5. This should be equal to negative 1 over 3. Now cross multiplying, we will have 3y minus 19.5, and this should be equal to negative x plus 2.5. Now again, negative x can come this side, so that we have 3y plus x, and then 19 crosses, so that we have 22. That is positive 19 plus 2.5. I mean positive 19.5 plus 2.5. And this gives us the second equation. Now we are going to solve these two equations simultaneously. So we have equation 1 and equation 2. So if we may arrange them as follows, we have 3y plus x is equal to 22. That is for equation 2. And then you also have the second, or rather the other equation 1, 2y plus x is equal to 21.5. Already we have this term here, x and x similar, so we can eliminate x for this case by subtracting the two equations. So if we have this equation minus this, we'll have 3y minus 2y, that is y, plus 0. So x minus x is 0. And then the right hand side we have 22 minus 21.5 is 0.5. So y is 0.5. And if y is 0.5, we'll have any of these two equations. For example, if we have 2y, which is now 1, that is 2 times 0.5, plus x equals 21.5. That means x is equal to 20.5. That is 1 goes to the other side, we subtract, and x is 20.5. So we have the x coordinate as 20.5 and the y coordinate as 0.5. That means the center of the circle, xy, is now given as 20.5, 0.5. And thus we have come to the final end of the solution to this problem. Thank you for watching. Bye.